Hey guys, it's Dan. Let's talk about logarithmic graphs like this. So notice we have f of x equals the log of x plus 2 base 3, and then plus 1 is tacked on. There's a bunch of ways to do this. One way is to use the change of base formula, put it in a graphing calculator and graph it. The graph's going to look like this over here. Another way is to use the change of base formula if you don't have a graphing calculator and change the problem from this to this. So using the change of base, it's the log of this on top divided by the log of 3 on the bottom, and that's base 10. So I'm using the change of base formula, and then plus 1 is tacked on. Now if you do that and you make a chart, you're taking 0 and putting it in there and doing the log of 2 divided by the log of 3 and then plus 1 to get that all the way down. So look at these values. So if you put 1 in, that becomes the log of 3 on the top and the log of 3 on the bottom. So you divide those and then add 1, you get 2. So I did several of these here and even here. So notice that you cannot use -2 for x because that is an undefined term. You can't take the log of 0. You also can't take the log of a negative number. So the domain is not over here. There's an asymptote at x equals -2, and this function is defined for x values that are greater than -2. So this goes to the right forever, it goes down forever. So it's coming out of -infinity here, very close to this asymptote, and then gradually turns and goes that way. So the domain is x values greater than -2. The range would be all the real numbers because this goes up forever, it goes down forever. As x approaches infinity, y approaches infinity, or f of x approaches infinity. As x approaches -2, y or f of x approaches -infinity, because as this gets closer to -2 over here, it's going down forever. The y-intercept evidently is 0, 1.63, if I have calculated that correctly. I think I have. So 0 and about 1.63. Anyway, so that's one way to graph this without a graphing calculator, and we're using the change of base formula. That works out pretty well. See ya.